Hey everyone, welcome back. It's SV Math Teach here, reminding you to smash that button if you like what you're seeing. And with that said, let's get started. Today we're going to work on scatter plots as an introduction. We're going to simply use scatter plots as a way to look for trends that may or may not exist. Let me give you an example. Something I learned early on in trying to make videos for students is that the longer those videos went, the less views I received. And I went ahead and I actually charted some, well, I gotta be honest, I just made this stuff up. But I used that idea to create the example for the video today. So I have some text here. I've already filled in some things, so follow along with me. I wrote down scatter plots are used to, first, scatter plots. What are scatter plots, right? The thing that you see on the top here, this is a scatter plot. It looks like a regular graph. It has an x-axis. We usually refer to those as your independent variable or your inputs. It has a y-axis. We call those the dependent variable or the output. But it's important that you have both, right? You have an input and you have an output. Or you sometimes have like the thing that you're looking at, and then the thing that might be dependent upon that thing you're looking at. In this case, the length of a YouTube video and how many views it gets. So scatter plots are used to examine two different sets of data, in this case, length of a video and the number of views, and to investigate the possible relationship between those two quantities. There might be a relationship between these and there might not be. If there's a relationship, that relationship is referred to as a correlation. Now I have the 5 different examples of correlations down here. Now, yours might look different than mine, and they can all look a little different, but these are rough estimates, right? The first one is going to be what's considered a weak positive correlation, and then next to it, I'm going to list a strong positive correlation. What you might notice is in both examples, our data kind of generally follows an up and right pathway. But the weaker one, while it goes up and right also, the dots are simply more spread out, and in the stronger one, they're more tightly clustered. It's not a cluster, but they're more tightly packed together. My highlighter didn't need to be as thick. Same idea for the weak negative. The idea of weak is that it is more spread out, and strong means it's more tightly packed together. Those are both negative, however. So negative is down and to the right, whereas positive was up and to the right. And then the last one over here is the no correlation. There's no relationship between these two things. Think hair length and IQ. There's no relationship between those two things. The longer or shorter your hair is doesn't make you smarter or less smart. So that would be an example of a no correlation. I have a fill in the blank section here, a positive correlation, right? So we looked at positive correlations. There are these two here. Positive correlations look like this. Both sets of data increase or decrease together. So either both sets of data are going up or both sets of data are going down at the same time. That's not, and let's also be clear, positive and negative do not mean good or bad. Positive and negative mathematically simply mean both sets of data are going up or both sets of data are going down. If you have a negative correlation, one set of data increases while the other, one increases while the other decreases. All right, one goes up, one goes down. And the no correlation means the data sets are not related. Now I have my one example. We'll answer a couple questions and we're all done for this introductory video. At first, I have length of a YouTube video is my input. We call that our independent variable. And our output is our number of views. I'm trying to see if the length of the video has any relationship between the number of views or not. It definitely appears that there is a relationship. If I try to kind of highlight the data, I feel like I have a trend of some sort. So let's see if we can answer some questions. As the video length goes up, so as the length of the video goes from 2 minutes to 4 minutes to 6 minutes to 8 minutes to 9 minutes, as this moves to the right, the dots get lower, right? You'll see that these are kind of high up and then they get lower and lower. As a trend, I see something there. So as the video length goes up, what happens to the number of views? The number of views decreases. And what you might notice is if we have one thing going up and the other thing going down, we refer to that as a negative correlation. Now that's not what's being asked for in question number 2, but it is what's being asked for in question number 3. Choose the correct correlation that best represents the scatter plot. Negative correlation all day long. And then back to question 2, there is a relationship between video length and the number of views. We definitely seem to observe this, right? We observe a negative correlation, so there is a relationship. So we're going to go ahead and say yes, there is a relationship. And that's really all there is to step 1 of scatter plots.